Hi, good afternoon to one and all. My name is Bhavani. I am from K.B.N College, Department of Physics and Electronics. So, now we are going to discuss about memory devices and logic families. Okay? So, these are the memory concepts. It's nothing but general memory operations: ROM, RAM, ROM, EPROM, EEPROM, EAROM. So, these are the general memory concepts. Okay? So now discuss what is memory. A memory is just like a human brain. It is used to store data and instructions. Computer memory is the storage space in computer where data is to be processed and instructions required for processing are stored. So memory is nothing but human brain. So it means we can store the data and we can access the data. So here we have two types of memories. It's nothing but internal memory and external memory. Next, so what is RAM? RAM is nothing but random access memory. So this is the one of the memory in CPU storage data. So here we can write the data and read the data. Both bidirectional process will be executed. So we have two types of RAMs. Is nothing but static RAM and dynamic RAM. Static RAM is nothing but internal RAM. So and dynamic RAM is nothing but external RAM. In static, when compared to the difference between static and dynamic RAM is nothing but, so in static RAM low power consumption will be occurred, and dynamic RAM it will be high power consumption. So next, coming to SRAM is nothing but, here data will be read and write as a simple formation, and dynamic RAM it will be data read and write complexions will be more. So next, this is the temporary RAM location. And coming to next slide, ROM is nothing but read only memory. It means here we can only read, so no write access will be there. So ROM stands for read only memory, the memory from which we can only read out but can't write on it. So this type of memory is non-volatile. When RAM is a volatile memory, but ROM is non-volatile memory, the information will be stored in permanently. So here we have some types of ROMs. There is nothing but PROM. PROM means programmable read-only memory, and EPROM it means erasable and programmable read-only memory. EEPROM means electrically erasable and programmable read-only memory. EAPROM means electrically alertable read-only memory. These are the different types of ROMs. So it means PROM means here we are going to read only memory. It means program will be read. So it means this is the permanent memory location. We can't write it and we can't edit it. So next, erasable. So here we can edit some type of user defined functions, some libraries. Here we can erasable. Next, electrical. Electrically means here we are giving to the some supply to the microcontroller and some memory locations. Next, electrically alertable. It means we get the acknowledgement from the memory locations. Here we can read the memories. We can read the data as well as programs. So coming to next slide. So before slide we saw the different types of ROMs and RAMs. Now we are going to discuss about ICs, logic families. So nowadays we are going to learn different technologies, and it means the world will be run in the IT technology. So IT technology means here we have to electrical gadgets are there, so that gadgets will be manufactured by using ICs. IC means integrated circuits. So these integrated circuits are made from semiconductor materials, so from different manufacturing companies. So now we are going to discuss what are different types of ICs and logic families. So every function, every program in the world will be run using these logic gates. So now we are discussing some logic gates. They are nothing but RTL logic, DTL logic, TTL logic, CMOS, NAND and NOR gates, CMOS inverters. These are the different types of logic families. Now we will discuss about one by one. So let's see what is logic family. Logic family is a collection of different integrated circuit chips that have similar input, output and internal circuit characteristics, but they perform different logic gate functions such as NAND, NOR, OR, NOT, etc. These are the different logic gates. So now here we can see the block diagram of logic family. So logic family consists of two types. It means unipolar and bipolar. Unipolar have some types. It means PMOS, NMOS, CMOS. And bipolar have two types, non-saturated and saturated. In coming to non-saturated, TTL logic and emitter coupled logic. These two comes under non-saturated. When saturated have RTL, DTL, TTL. These are the different types of logics. So every logic will perform different operations and different algorithms. Now see one by one. So RTL was widely used before the development of ICs. IC means integrated circuits. So before development of ICs, we are going to use RTL logics. RTL circuits are made of resistors, transistors are the first logic families to be integrated. Although RTL resistors transistor logics is not used much now, but studying its principle is beneficially in understanding the working of other gates. Inverters, OR, NOR, NAND logic functions can be realized in this system. So when compared to ICs, RTL logics some little bit use is less, but RTL is principle is very useful. So here we can see the diagram of RTL. So here we use two transistors and resistors. So we have to connect the resistors, transistors in some directions. Here we are giving to the some voltage and some ground. So now this circuit will be performed in different sectors. That means when we have to perform in NOR and NAND gates or functionalities, so now we have to discuss about RTL principle. So this is the about RTL. Next, coming to DTL. DTL means diode transistor logic, belongs to the logic circuits formed by the diode family. So diode is nothing but back-to-back connection of one transistor. So here we have diode have two terminals. So the logic circuit of DTL has input sides connected to the diodes and outputs are connected to the transistors. So here input is diode and transistor is output. So the connection between input and output, this is nothing but DTL logic. So here we have some advantage. This is nothing but it has high noise margin and higher values of the fan out. So noise differences are the more. So DTL means diode TTL logic. We have to learn some concepts in DTL. Next, coming to next slide, TTL logic. When compared to DTL and RTL, TTL is the most versatile logic circuit in the world. So most of the cases, most of the circuit connections, most of the microprocessor, so everyday life we are going to use TTL logic only. TTL means transistor logic is a popular digital logic family that was widely used in the design of integrated circuits. So integrated circuits. Here some key points are there. So TTL logic circuits are constructed using bipolar junction transistors and resistors. So bipolar junction means it have bidirection. It means transistor logic. It can send the data and receiving the data using that characteristics. So the basic building block of TTL is NAND gate. So TTL logic will be built using NAND gates only, which can be used to implement all other logic gates such as AND, OR and NOT gates. So the basic building block gate is NAND gate. So for the TTL, because AND, OR, NOT gates are NOT gates are manufactured and designed using TTL logic. TTL used NAND gates. So this is the communication. So TTL gates are characterized by their high speed, low cost TTL voltages within specific ranges. The range is 0 and logic 0 and 1. We all know that logic 0 means low voltage, logic 1 means high voltage. Here some range is given. So when 0 volts, 0 to 0.8 volts is considered as logic 0, while voltage is range of 2 volts to 5 volts, it's considered as logic 1, it means high voltage. Next, coming to CMOS, NAND or NOR gates. So CMOS is nothing but complementary metal oxide semiconductor. So this is the device when used, when designed ICs, integrated circuits and chips, some voltage regulator chips. Not only voltage regulators, some integrated circuits are mostly manufactured using this type of logic gates. So NAND or NOR gates are two fundamental logic gates in the CMOS logic family. CMOS technology is widely used in modern integrated circuits due to this low power consumption, high noise immunity and capability with a wide range of supply voltages. So we have some different types of advantages while using the CMOS technology. So mostly we are worried about electricity, so power consumption. So when using CMOS technology, so power will be less and voltages will be less. So this is the about CMOS technology. Here's some working. So CMOS NAND gate and NOR gate. CMOS NAND gate is constructed using the combination of both PMOS and NMOS. So PMOS means P-channel metal oxide semiconductor and NMOS is N-channel metal oxide semiconductor. P means positive terminals and N means negative terminal. It has multiple inputs and single output. So number of masters will be more and slave will be one. So coming to CMOS NOR gate. Similar to the CMOS NAND gate, CMOS NOR gate have PMOS channel and NMOS channel. Here we have some functionalities. So these are nothing but multiple inputs and single output. So both working CMOS NAND gate and NOR gate will be same. So coming to next, CMOS inverters. CMOS inverter also known as NOT gate. NOT means reverse condition. It means negative charge. So is one of the fundamental logic gates in CMOS technology. Inverter means reverse. So it performs the logic operation of inverting the input signal to its complementary output signal. So complements means 1. So CMOS inverter consists of PMOS transistor and NMOS transistor connected in specific configuration. PMOS means P channel, it means positive terminal, and NMOS means negative terminal. Okay. Next, CMOS inverter works. How it will be works. So here some concepts. So PMOS transistors, NMOS transistor, complementary operation and inversion. So PMOS means positive and NMOS means negative. So here the diagram. So PMOS means we have transistors. Transistor terminals is source and drain, and NMOS also have source and drain. So here two drains are connected to the output terminal and sources will be connected to the input terminal and ground will be connected. So this is the connection. Next, programmable logic devices. So when we are going to write some programs, some logics in embedded systems, we have to some rules and regulations. We have to follow that. So programmable logic devices. We have some logics like microcontroller, microprocessor use this type of logics. These are nothing but PLA. PLA means programmable logic array, and PAL, it means programmable array logic. Now discussing briefly programmable logic devices. Programmable logic devices are integrated circuits that can be configured by the user to implement various digital logic functions. They are widely used in digital circuit design and prototyping, as they offer flexibility and reconfigurability compared to fixed function logic device. So we have in microprocessor or controllers, we have some fixed logics and fixed functionalities. When compared to that functionalities, we have to going to with this type of logic devices. So they are nothing but two types. It means first one is the programmable logic array. Array is a collection of elements in series. So a programmable logic array is a type of programmable logic device that is used to implement combinational logic circuits. It consists of a fixed AND array and programmable array. AND means multiplication and OR means addition. So fixed multiplication will be there and programmable OR. So here we can edit the OR conditions. Next, which follows for the flexible logic function implementation. Next, coming to the PAL. PAL means programmable array logic, is a type of programmable logic device that is used to implement combinational and sequential circuits. It provides flexible and efficient solution for the custom logic implementation. It means flexibility will be more when compared to other logic devices. These two logic devices are used in microprocessor and controllers for the best and better performance in when we are writing to the program. These are the different conditions. Thank you for giving this opportunity. Thank you.